Hi everyone, welcome back. So in this video we are going to discuss again KVPY questions, practice question, and topic for this video is atoms, molecules, mode concept and stoichiometry. So it's mainly focused on essay part, that is for the first year students. Let us solve. Yes, the first question. What shall be the percentage abundance of B11 if 10.8 is its average atomic mass? Consider B10 to be other stable isotope. So we know that average atomic mass is equal to A1x1 plus A2x2 divided by x1 plus x2, where x1 and x2 are abundances, percentage abundance. Then A1 and A2 are atomic masses of respective isotope. So considering only two isotopes exist, it will be like 11 into x plus 10 into 100 minus x divided by 100 is equal to 10.8. So it's 10,800 is equal to x plus 1000. It's 1080 in fact. It's 1080. Is equal to x plus 1000. So that gives x equal to 80. So that's option C. Let us move on to next question. Yes. Two oxides of metal were found to contain 31.6% and 48% of oxygen respectively. If the formula of first is represented by M2O3, find the molecular formula of the second. So molecular formula of the other. Very simple. Say for first oxide, the mass of, suppose we consider 100 gram of oxide, then number of atoms of metal in. So here 31.6% oxygen actually, 31.6% oxygen. Then remaining is how much? 68.4% will be metal. The number of atoms of metal in 68.4 gram is equal to 2, suppose. And number of oxygen atoms in 31.6 gram is actually 2. Not 2, it's 3. 3 atoms. Here it is 2 atoms. So this is only assumption. Now, if we see number of atoms for the second oxide is actually going to have 52 gram of metal. So, if we write second oxide has 48% oxygen and 52% metal. So number of atoms for 52 gram of metal is very it's a unitary method. What we can do is we can multiply 52 into 2 divided by 68.4. So for 68.4 we have seen two atoms. For 52 it will be if we calculate we get almost 1.5. Similarly, number of atoms of oxygen for 48 gram will be, so here 3 atom for 31.6 into 48. This will be 4.5. So now we can easily make out metal is to oxygen is equal to 1.5 is to 4.5 is equal to 1 is to 3. So you get easily option D. Now otherwise, instead of this way, if we go for a normal mole concept calculation, then it will be a bit tedious, but let us look at that. The first oxide has M2O3 formula, molar mass of, let molar mass of metal be M. Then 68.4, which is the percentage of metal, is equal to 2 into M divided by 48 plus 2M. So on solving this, we get M is equal to almost 52 gram per mole. So if M is 52 gram per mole, then we can easily calculate formula for second oxide, because percentage is known. Now molar mass is also known. We can easily find out the molecular formula. So percentage of M is 52%, oxygen is 48%. So in 100 gram, 52 gram will be M only. So number of atoms is equal to 1. 48 by 16 is 3. So it's very easy. You can get MO3. So that itself will be the molecular formula. So that's how you can calculate using mole concept also. So this seems to be more appealing than the previous one, because previous one involves a lot of logic. Let us move on to the next question. Predict the hybridization of central atom in the molecule in which percentage of sulfur is 22% and that of fluorine is 78%. Okay, so sulfur is there, fluorine is there. Percentage is 22 here and here it is 78. So number of atoms, or we can say number of gram atoms in 100 gram compound is 22 divided by 32, because sulfur is 32, and here 78 divided by 19. So fluorine has atomic mass of 19. So now if we calculate this, this will come out as 0.6875, and this will come out as 4.105. So in this way you get number of gram atoms. Now relative number of atoms. Now if you see relative number of atoms, so this will be 6. It's almost like 5.98, so almost 6. So empirical formula for sulfur compound is SF6. We know that there is a compound by the formula SF6. So now for this hybridization has to be found out. So if you look at the valence electrons of sulfur and fluorine, it is 6 plus 7 into 6. So total 48 electrons, which are total valence electrons. So if you divide this by 6, it will be 6. I mean, if you divide it by 8, you will get 6 and remainder will be 0. So this pair, first pair indicates, first number indicates number of bond pairs and second one will indicate number of lone pair. So there are 6 bond pairs and 0 lone pair, that means it is sp3b2 hybrid. That will be the answer. So let us move on to next question. Hemoglobin contains 0.25% iron by weight. If molecular weight of hemoglobin is 89,600 U, number of iron atom per molecule of hemoglobin is very simple, based on percentage composition. So percentage of Fe is equal to X into 56 divided by, because 56 is mass of atomic mass of Fe, divided by molar mass of hemoglobin. Molar mass of hemoglobin. So now if we see, this will be equal to 0.25, of course here multiply by 100, 5600 into X divided by 89600. So it's like X equal to 4. So approximately we get same answer. In fact, it's exactly 4. So that is the answer. 4 atoms will be there. Option C will be the answer. Let us move on to the next question. Molarity and molality of the solution formed by mixing equal volume of 30% by weight H₂SO4 and 70% by weight H₂SO4. Densities are given. Okay. So this will be quite lengthy question. Let us see. First let us find out the masses of H₂SO4 from each sample. So we have mixed equal volume. So let volume of each sample taken be VML. So mass of H₂SO4 in 100 gram solution is equal to 30 grams. So volume of solution. Volume of solution has to be calculated by mass by density. So mass is 100. Total mass of solution is 100. That's what we have considered. Divided by density is 1.218. This will be ml, because we have considered gram per ml as the density unit. So this is the volume of 100 gram of solution, but we have taken VML. So mass of H₂SO4 in V ml of sample, because 100 gram of sample has 30 gram of H₂SO4. So the point is, this much ml has 30 gram, VML has how many grams? So it's a unitary method. You can see 100 by 1.218 has 30 grams. We want VML, how much? So it's like 30 into V into 1.218 divided by 100. Grams will be the mass of H₂SO4 in VML of first sample. So sample 1 here. Similarly, we can have sample 2. This is not visible. Sample 2. For sample 2, in similar way, if we calculate, because it is 70% H₂SO4, the volume of solution will be 100 gram divided by the density is 1.610 milliliter, and because it is 70% by mass of H₂SO4 in VML of sample 2 is equal to, it's going to be 70 V into 1.6 divided by 100. Basically it's 1.610 divided by 100. So we have got two values now. Mass of H₂SO4 from sample 1 and mass of H₂SO4 from sample 2. And we have total volume 2V. So we can easily find out the molarity. So let us find out molarity now. So total mass of H₂SO4 is equal to 30V into 1.218 plus divided by 100 plus 70V into 1.610 divided by 100. This is actually grams. So molarity is equal to mass divided by 98, that is the molar mass of sulfuric acid, into volume into 1000. Because our volume is in milliliter, we have to multiply by 1000. So in this way, we can get 1000 into, so if we add here, this will become 30 into 1.2 plus 70 into 1.6 will give 149.2 for V divided by 100. This is the mass of H₂SO4. So 1000 into mass divided by 98 into 2V. 2V is because we have volume of each sample taken as V. So very simple. It's going to be 1000, in the sense it's going to be 10, and the value calculation of the values in the expression from 1492.4 divided by 98 7.61 will come. This is molarity. Now molality. So for calculating molality, there is only one way. Weight of total solution is needed. Weight of solvent is needed. So for that we have to find out mass of solvent is equal to, they have given density of the solution. So let us multiply density into volume. So 2V into 1. If you look at the density of the resulting solution, 1.425. So that will be 1.425. This is actually the mass of solvent in milliliter, minus 1. See here, this mass, if we actually calculate, this will give 1.4924 V grams. So basically 1.49 we can consider, or 1.5, 1.4924. I have used calculator, so I'm giving exact values, is equal to, so this will come out to be somewhere like, it will be 1.357 V grams. Okay. So this is the mass of solvent. So same. Now molality, small m, is equal to number of moles. So you can say mass divided by 98 into 1.357 into 1000 V, because this is actually the mass of solvent. It's in grams, so we have to convert it into kg, so multiply by 1000. So in this way our value will become, again, mass is 1.4924 V divided by 98 into 1.357 V into 1000. So this is almost like around 10 it should be. So if we calculate, we get it as 11.2. So our answer is very clear. So one molarity here and molality here. So this was a quite lengthy question. However, our answer is option A. So molarity first and then molality. Let us move on to the next question. In the following reaction, A undergoes ozonolysis to give 60% yield of both B and C. If 11 gram of A undergoes reaction to form 5.04 gram of C, the mass of B formed will be. So A is this, and its molar mass, we have to find out molar mass of each species now. So here 1, 2, 3, 4, 5, 6, 7, 8. So molar mass of this is 96 plus 3 plus 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 110. Yeah, there is no carbon here. It's actually 14 only. So it's 110. So 11 gram means 0.1 mole. So 11 by 110 is equal to 0.1 mole. And only 60% yield is obtained. That means, see, 1 mole of this reactant on ozonolysis gives 2 products. On this product, another one will be acetone. These are the 2 products obtained by ozonolysis. So that's very simple reaction, organic reaction. I am very sure you know the mechanism of ozonolysis. If you have not come across ozonolysis mechanism, you can surely go through NCERT book. You will get the mechanism. I mean, you will be able to make out how to get the product. So here, the point is each of them will form stoichiometrically 0.1 mole of each, but only 60% yield is obtained. So moles of B obtained, we want the mass of B formed is equal to 0.1 into 60 by 100. So how much is this? 0.06 moles. So 0.06 moles of B is obtained because only 60% yield is there. So here they have given mass of C, which is actually not necessary here because anyway by using mole concept we can always calculate 0.06 into molar mass of this compound is 1, 2, 3, 4, 5. That is 60 plus 8 plus 16. 84. So 84 is the molar mass of B. Okay. So B should contain 3 carbon atom here. We would have missed it now. So this should be the one which we are calculating. So they have given C. So here 1, 2, 3. So the molar mass of this is 36 plus 6 plus 16. 8, 58. So this is the molar mass of acetone. So it's going to be 3.48 grams. So option 2 is correct answer. Let us move on to next question. A droplet of water is falling from certain height and water gets vaporized as it falls down. So a water droplet is falling. It is, it gets vaporized as it falls. What number of water molecules are vaporized from spherical droplet of volume 1 ml if its mass is reduced by 20% just before it touches the surface? So before it touches the surface, it's some quantity of water is lost as a vaporization. Now 20% mass is lost. So if its mass is reduced by 20%, that means loss of water is equal to 20%. Now initial volume of this is 1 ml, that means it is 1 gram because water has a density of 1 gram per milliliter. It's already mentioned. So loss of water is 20% of 1 gram. So 0.2 gram. This much water is lost. So number of molecules of H₂SO lost is equal to 0.2 divided by 18. This will give number of moles of water lost into Avogadro number 6.02 into 10 power 23. So that will give me answer of 6.69, that means 6.7 into 10 power 21. This will be the number of molecules lost. So this many water molecules are lost before water reaches the surface. The next question. Percentage purity of a sample of sodium bicarbonate 2.4 gram of which gave 2.27 liter of CO2 at STP is. So very simple. First we need a balanced chemical reaction here. NaHCO3 on decomposition gives Na2CO3 plus CO2 plus H₂O. They have asked, they have given the volume of CO2 obtained at STP. And here it's Na2CO3, so it has to be balanced like this. 2 moles of NaHCO3 will give Na2CO3, CO2, H₂O. Yes, this is balanced now. Very simple. Number of moles of carbon dioxide produced is 2.27 divided by 22.7, because at STP they have given the definition 1 bar and 273.15 Kelvin. That means you have to take STP volume as 22.7. So it's 1 by 10 mole. 1 by 10 mole. That means number of moles of NaHCO3 reacted should be equal to 2 into number of moles of CO2 formed. That's the mole concept here. 2 moles of NaHCO3 will give 1 mole of CO2. So here it's 2 into 1 by 10 mole. So this will be equal to, because we want to find out percentage purity, we need mass. Or we can calculate by moles also, but let us be very clear. We can find out mass here. W NaHCO3 is equal to 2 by 10 into the molar mass. Molar mass of NaHCO3 is 24 plus 60, that's 84. 84 into 2 by 10. So it's like 16.8 grams. So only 16.8 gram of pure NaHCO3 is required for producing 2.27 liter of CO2. However, how much is being reacted, you see here, 22.4 gram of sample is reacted. So percentage purity of sample is equal to 16.8 out of 22.4 into 100. So this will be something like 3 by 4, that means 75%. So option C will be the answer. Let us move on to next question. Total number of ions furnished by 100 ml of M by 8 solution of H₂SO4 if sulfuric acid dissociates as follows. So they have already given the reaction. Total number of ions is being asked. So here you have 1 and here 2. So total 3 moles of ions are produced by 1 mole of H₂SO4. This is the important point to make out from the given information. So number of moles of H₂SO4 available is equal to molarity into volume, that is M by 8, that means it's 1 by 8 into 100. So it's like 25 by 2 millimoles. That means if 1 mole of H₂SO4 gives 3 moles, 25 by 2 mole will give total moles of ion is equal to 3 into 25 by 2. So number of ions is equal to 75 by 2 into 6.02 into 10 power 23. So how much will be the number? Of course, this is millimoles. So it's going to be 20, because 10 power minus 3 will get cancelled out. So 75 into 6.022 into 10 power 23 divided by 2. So 2.258. So it's equal to 2.26 into 10 power 21. Is it 21 or 22? It's 22. So it's option A. 2.26 into 10 power 22. That is the answer. So let us move on to next question. Molality of sulfuric acid, which is 18 molar and has density 1.8 gram per ml. 18 molar. So molarity is given. Molarity is equal to 18 m. We want molality. We have a direct formula also. Direct formula for molality, density is given. So we can note this. B solution is equal to molarity into molar mass of solute divided by 1000 plus 1 by small m. So this is also one way of calculating small m. But of course, here everything is known. I will calculate in a conceptual way, means not using this shortcut formula, because it's always difficult to memorize this formula. So rather than that, we can simply consider 1 liter of solution. So we need moles of H₂SO4 divided by mass of H₂O into 1000. So this should be in grams if it is multiplied by 1000. So if I take 1 liter of solution, then 18 moles will be the number of moles of H₂SO4, because the molarity is 18 m. And mass of H₂O is what we want to find out here. They have given density. So mass is equal to volume into density. So 1000 into 1.8 minus 18 into 98. Because 98 is molar mass of sulfuric acid. 18 moles are present. So we have to subtract this mass of solute from the solution into 1000. So this on calculation will form, will give the answer as, it is 1800 minus 18 into 98 is equal to 500 is what I get. So 500 m. So molality will be 500. So that's the answer. So that's it for this video. Bye. Have a nice practice. Meet you in next video. Thank you.